Let's practice a little bit more with these parabolas. So I want to find the standard form of the parabola. I want to find the vertex, focus, the directrix, sketchograph. I want to do everything associated with this parabola. Here in front of me, I have a parabola x squared minus 4y plus 2x minus 6 equals 0. This parabola is not in the standard form. This is a general form equation. It's set equal to 0. It's all multiplied out. So we do want to go into standard form. Now I do want to stress for a minute that we had the standard form of quadratics. Quadratics, we had standard form y equals a x minus h squared plus k. That is the standard form of a quadratic, not of a parabola. So remember the difference between quadratics and parabolas. Well, quadratics are a type, a parabola is the graph of a quadratic. It's the type of equation it is. But a quadratic is kind of a subset of that. It is just the parabola that opens up and down. We also have the parabolas that open left and right. So again, I'm going to not forget this, but I'm just not using this through this section. We want to find the standard form of the parabola. And so those, remember, x minus h squared equals 4p y minus k, or y minus k squared equals 4p x minus h. And so just kind of compare and contrast, why do we have these two different forms? Well, quadratics, that standard form is great. It gives me the vertex. It allows me to see which way it opens, but it doesn't give me the focus. It doesn't give me that p-value to help me find the focus. The directrix doesn't give me that width at the focus point. So there's a lot of things that this standard form of a parabola do for me that the quadratic standard form can't do. And on top of that, if we have an equation that's not a function, for instance a y squared equation, we wouldn't be able to solve that with the quadratic equation because it's not quadratic. Alright, so here we have an x squared minus 4y plus 2x minus 6, and so we have to be thinking about which of these two forms do we want to go into. Well, we have the x squared equation. We're going to want to go into this form right here. It is going to be the traditional quadratic equation that opens up, down, left, right, but we want to put it into this new standard form of a parabola. So what I'm going to do, I'm going to have to complete the square. In order to get it from this form to this form, I'll have to complete the square. So I'm going to start by moving the x terms together. I'll leave myself a blank. I'll move the y terms and the constant terms to the other side. In the same way we've done with completing the square before, if I have a blank over here, I have to place a blank on the right hand side too. And that's, technically you don't have to place it there, you just have to remember to add the number to both sides. I like to go ahead and put those blanks there just to remind me that, hey, I actually have to do that, I have to add it to both sides of the equation. So now we're going to complete the square. So I look at the center number and I say, okay, what's half of 2? The answer to that would be 1. I'm going to square it. Well, 1 squared is 1. And there's a reason I leave it not multiplied out on the left hand side and I multiplied it on the right hand side. It's just to make this next step a little bit easier. Because of the way I've chosen that 1, I get the perfect square, x plus 1 squared equals, and then on this right hand side I have a 4y plus 7. And so because I've left it in that squared version on the left hand side, that's exactly the number that's dropping down there. On the right hand side I need a usable number to be able to add, that's why I squared it. Now granted, 1 squared we can pretty easily see it's 1, but I'm going to continue to do this kind of pattern where I don't square it out on the left hand side so I can see exactly what needs to be here. On the right hand side I'm going to square it out so I can see what they add to. So again, why is it that this perfect square x plus 1 works out? Well, remember how we treat perfect squares. You square the first term, you square the last term, you multiply the two and you double it to center. And so we're just undoing that process. We're saying, okay, let's half that and then square it to get that perfect square. Not quite in standard form yet. I need to go ahead and move the coefficient off the y. So I'm just factoring off whatever is in front. It does not matter what the number is, whatever it is, I'm just factoring it off. So once I've factored that off, I have a fraction left, 7/4. Don't be afraid of fractions, they're fine numbers. So now that I have it in the standard form, that is the standard form of a parabola, I can see what's going on with this shape. So first thing I think is always helpful is just again to remind ourselves which way it's opening. Is it going up, down, left, right? Because it's an x squared, the traditional quadratic form, it is going to go up and or down can't be and or down. And because it's positive p-value, then it's going to have to be up. So we know it's going to look like this. That's just kind of a rough approximation. Let's get the more detailed points. So our vertex is going to be -1, -7/4. We reverse both the signs. We have the -1 and the -7/4. I need to find the P next to be able to find the vertex, the directrix, sorry, the focus and the directrix. Well, 4P is equal to 4. That's just that coefficient right there. This is the 4P term. And so P is equal to a 1. All right, so at this point, let me maybe make that sketch a little bit more detailed just so we can really think about what's going on. We started at -1, -7/4, so that would be approximately here. And we're going up by 1 unit, and so that clearly shows us that we're going to be adding to the y coordinate. So the x isn't changing. We take 1 and add it to the -7/4, that's a -3/4. So that's going to be our focal point. The directrix moves the opposite way. So if we just moved from here up to here to get to the focus, we're going to have to move down to get to the directrix. It's going to be underneath here. So the directrix, well, for one thing, it needs to be an equation. It is a line, and it is, in this case, a horizontal line, so that's going to be of the form y is equal to. Well, we just had a vertex value of -7/4, so if we subtract 1 from that, it's going to be a -11/4. So now we can get a pretty accurate sketch. This one still isn't great. I'm not going to make that my final sketch because I just kind of arbitrarily drew its width there, and I want to be a little bit better than that. So let me go ahead and put my points on there again. We have our vertex -1, -7/4. I'll label things as we go along too, because there's going to be a lot of points on this graph. Helps me keep everything straight. My focus is at -1 3/4, so 1 unit above. And then 1 unit underneath, so just shy of the -3, -2 and a third. We'd get our directrix, and again, just labeling everything so I don't forget what everything is. The challenge though is I don't know if is it supposed to be really narrow, is it supposed to be very sweeping, and so even though I haven't asked you to find it, this is where I'm going to find the length of the lattice rectum, because that shows me exactly how wide it needs to be. And so that will be exactly what the 4p was, or that coefficient was before we divided it by 4. That'll be 4 units. So that tells me at the focus I should travel 2 units to the right, and then 2 units to the left. Extend out my axis. Try and make those points a little bit more connected. A little better scaling there. And so we can see that that's going to be the sweep of the parabola. And again, why did I go left and right by 2? Well, if the whole span is 4, well, from center I need to be going left and right by 2. So that's how I got there. Let's take another example. Let's say we have x plus 4y plus y squared minus 2 equals 0. Once again, we have a general form equation. It's all been multiplied out, set equal to 0. I need to get into standard form first, so let's do that. Well, first thing I'm going to do is rearrange. I'm going to get my y's together this time. I'm going to leave myself a blank. I'm going to move the x's and the constants to the other side. Why is it that I got the y's together? Well, because the y's are being squared. And so again, thinking about those standard forms of a parabola, we're looking at this one right here. We want the y minus k squared equals the rest of whatever we have. So that's why I've gotten the y's on the left-hand side. When I think about what I have to add to both sides, half of 4 is 2. I'm going to square it, and 2 squared is a 4. And so we'll have a y plus 2 squared equals -x plus 6. I have my perfect square. Notice that 2 has just dropped directly down. This is, again, why I'm not squaring it here, so I can see what it needs to be. On the right-hand side, though, I've squared it so I could see what I got when I added it. And I need to finish factoring off what's in front of the x. Now, it's only a -1, or a negative, you don't have to write the -1, but negative. I need to factor it off because that's going to change my vertex, and of course it's going to affect my p. This parabola is a y squared equation. That is not a function. It means it's going to open left and right. because it's a negative p-value, it is going to open to the left. So everything I do, I'm going to keep in mind this thing is opening to the left. Let's go ahead and get the vertex. The vertex is the point 6, -2. Opposite direction this time because the x's are over here and the y's are over here, so I had to look on the right hand side first. To find the focus in the directrix, I'm going to need the p. Well, 4p is equal to a -1, so p is equal to -1/4. And so from the vertex, I'm going to have to move to the left by -1/4. That means it's making it smaller, subtracting. I'd have 5 3/4. You could also write that as 23/4. I think sometimes it's easier to use the fractions. But again, we're just taking -6 and subtracting the 1/4. So 5 3/4, 23/4. The directrix will be a line moving the opposite direction. If this is a focus, the directrix will have to be over here. It is going to be a vertical line, which means it needs to be of the form x is equal to. If we just subtracted the 1/4 to get to the focus, we're going to have to add the 1/4 to get to the directrix. So that would be 6 1/4 or 25 over 4, and that would make sense because I was just doing quick mental math. We need to see that we have 2/4 in between these two things. The p tells us how far to move to the left and the right, so notice we have 2/4 in between them, so that's perfect. And so then I'm going to go ahead and get my more accurate sketch, and just like before, in order to determine that width, I'm going to need the length of the last rectum. And that will be exactly what we had before we divided off the 4, or the 1. It's going to be the absolute value of that. It is a length, and lengths are always positive. So that's the one difference between just simply looking at this coefficient value and taking that directly. It has to be the positive version. So now I've got everything I need. The vertex again, positive 6, -2. 4, 5, 6, -2. So there's my vertex. My focus, we moved just a tiny bit to the left, and so barely any space in between, and that's probably even too much, but just to really kind of see the difference, I'm going to put it there. And then the directrix, again, just barely quarter unit to the right. And so then from that focus, I need to travel a full unit, which means I'm going a half unit up and down. Again, very, very slight. If that's a unit, we're only going a half unit. And so we can see we're going to have a very, very tight parabola pointing to the left, which is what we expected.